Hello, my name is Ronit Avadhuta, and today I'm going to teach you how to use Euler's method to approximate values of a function you may not even know, using purely its derivative function. So let's say you have some function f of x, and you don't know what it is, but what you are given is that its derivative function f prime of x is equal to x over 2y. What you're also given is that one point on the original function, f of 0, is equal to 2. So the question is now, what is f of 2? What does that equal to? So let's make a little chart, and let's just take some small steps to get to our final answer. Let's say that we have x over here, y over here, and our f prime of x over here. Now, let's start off with our original value. So 0, 2. So that's 0, 2. And okay, plugging into the original slope, that's 0 divided by 2 times 2, that's 0. Slope is 0 at this point. So now let's take our step of 1. So let's say the change in x is going to be 1 every time. So let's add in a 1. Okay, we add in the 1. Our slope is 0, so our y value is not really going to change. So we have 1, 2. We plug that into the slope. Let's find the slope at this point now. And let's say 1 over 2 times 2, that's 1/4. Now, what this is essentially doing is it's assuming that the slope of 0 remains constant among the range of the step. And same thing with the 1/4. We're going to assume that this remains constant over the range of this step of 1. So when it goes to 2 now, a change in x of 1 and the slope is 1/4. Okay, that means the change in y is going to be 1/4. That's going to add up to 1/4 over here. It's 2.25. And that gets you our final answer. Now let's look at another example with a slightly different order. Let's go work backwards. By this, let's say you have function f of x again. You don't know what it is. And let's look at its derivative function. Let's say that that's 2x minus 4y. You're also given that f of 1 is equal to 10. But now the question asks you, what is f of 0? So now you have to work backwards. So how are you going to work backwards? Is first, let's make our chart. Let's say we have x, y, and our f prime of x. Cool. Now our first value is going to be 1, 10. Now, unlike last time, we can choose whatever our delta x or a step can be as long as it remains constant. So let's go with, we want to go down. So let's say our delta x is negative half or 0.5. So if we have that, we know that, okay, we're going to go negative 0.5. Okay, cool. Then we're going to be left with 0.5. And eventually, we're going to reach this line where we have 0, which is, what we want. We want to find out what f of 0 is. But to do that, we're going to need these slopes. So if we have 1, 10, and plugging this into the equation, we're going to have 2 minus 40, which is going to leave us with an incredibly very large negative slope of negative 38. But if the change in x is negative 1/2 and the slope is negative 38, we just have to multiply these and we get 19 to see what the change in y is. So 19 on top of the 10 we have is going to be 29. Okay, but what's the slope at this point? That's going to be 1/2, 0.5 times 2, that's 1, minus 29 times 4, that's 116. So slope at this point is even more negative, 115. And what we're going to do is we're going to change by a negative 1/2. Change by negative 1/2 here is negative 1/2 times this negative 115 is going to leave us with a 57, positive 57.5. A 57.75 plus the existing 29 that we've been building upon is going to equal 86.5. Thus, we can conclude f of 0 is 86.5. Furthermore, we can look and let's try to see if we can possibly maybe even look at what the original graph was based on this information. So we know that the closer it gets to 0, coming from right to left, the closer we're getting to 0, the more steep it is becoming. So if we have a small little graph over here, we can see that, okay, it might be something like this. And okay, as it's 0, it might be over here. It might be over here. And it might be leveling out or something like that. We don't know too much information, but we can get a sort of general gist of it and approximate and estimate values. Thank you. I hope you learned something here today, and I wish you good luck.